Hello everyone, this is Tiger again. Well, I know I did a haircut and please don't laugh at my egg head. Well, I know it's not the best haircut I can get, but life is like a box of chocolate, right? So, yeah, that's how I become now. So, let's cut it short and bring on to our 2022 JMC paper, which is going to be the last past paper that we are doing together. So let's look at the first half of this paper today. And this half of the paper is going to be pretty easy. So let's take a look at what questions we have. All right. Moving on to question 1 right here. Question 1. So this is definitely a numbers and operations question. Numbers and operations. And it's just about the basic operations. So as long as you can calculate, you should be able to get this question right. So the first calculation leads to 42. The second one leads to 204. The third one leads to 404. The fourth one leads to 0 because there's a 0 in the multiplication. And the last one leads to 440. So apparently this has the largest value, right? So the answer is E. Easy one. And for question 2, well, this is a geometry question on reflection. And I suppose it won't be too much of a problem either, because you can easily imagine that if this is going left, then this line will be going right here. And, well, then you can sketch the shape of this, which you can already eliminate a lot of the options. And then the 1, of course, goes next. So you can eliminate C. And by common sense, you know that 5 and 2 looks differently, right? So E can't be the answer. So you don't even have to write the final 2 numbers, but there you go if you want them. So this is a 0 right there. And this is going right, yeah, from there to there. So it means that the last line should go left from there to there. And then, well, this is on the left of it, so it should be on the right of it. And follow the sketch. So you're going to get a 2 right there, yeah? So the answer is A. Okay, I guess I don't need to explain too much for the second one. As long as you know what is reflection, it means that each single line or each single point, if reflected, is going to be the same distance away from the mirror line as the original version of it. So the mirror image will be the same distance away from the mirror line as the original object or item. All right, and then for question 3, this is a very interesting question. There's sort of those kinds of magic like this, like playing with the numbers. So it belongs to the numbers and operations. And I would say it's still kind of like a number machine or defining new operation. Let's say new operation. All right, so think of any number. That's the keyword here. And then you add 5, multiply 2, add 10, divide by 2, subtract your original number, add 3, and what's the resulting number? Since it says that you can think of any number, it means that no matter what number you're thinking of, you're always going to get it right. So you can start with some simple numbers, say 1 or 0. And then, well, if you are using 1, you add 5, you get 6. Multiply by 2, you get 12. Add 10, you get 22. Divide by 2, you get 11. Subtract your original number, which is 1. Add 3, that's going to be 13. All right? So I'm not writing the whole calculation out because that's a lot of steps. But you can definitely do it with your mental maths, right? So I have complete faith in you for this one. And then for question 4, well, it's another easy one. I would say it's a gift, to be fair. Numbers and operations. And this time, we just need to convert fractions to decimals. And we will be able to calculate the answer. Why are we converting fractions to decimals? That's because all the answers are given in decimals, right? So what is 2/5 as a decimal? It is 0.4. So 0.6 adding 0.4 is going to be 1. So the answer is 1. That's it. As for question 5, well, even if it looks like a calculation question, but it is actually a number theory problem on divisibility. Because it is asking you how many of these take integer values. So first of all, 1/1 is 1, that's what we know. And then 11/2 is not an integer because 11 is not divisible by 2, right? And then what about 111/3? It is an integer, and that is equal to 37. Well, we know that because 111 is divisible by 3, right? The 3 ones adding together sums up to 3, which is a multiple of 3. So it's divisible by 3. So this third one is an integer. The fourth one clearly is not even an even number. So it can't be divisible by 4, right? 1, 1, 1, 1. And for the last one, it doesn't end with 0 or 5. So it can't be divisible by 5. Easy. Which means that only 2 of them is going to be divisible. Which means 2 of them are going to give integer values. That's it. As for question 6, so this is a very typical question. I believe that you have seen similar questions before in the previous papers. So a geometry question on angles. Now, first of all, you need to be familiar with the interior angles of equilateral triangles and squares, definitely. So I'm definitely knowing that the interior angles of the equilateral triangles are 60 degrees, and for the square it is 90 degrees, right? A right angle. And we're looking for the size of the angle QPU. So look at triangle QPU. What kind of triangle is this? Clearly, apart from the angles, we know that for equilateral triangles and squares, they have another property about sides. All the sides are going to be of the same length in equilateral triangles or squares, which means that QU is equal to UR, and UR is equal to UT, and UT is equal to PU, which means that triangle PUR is isosceles, right? Which means the 2 base angles are going to be the same. So it means PQU is equal to angle QPU, which is the angle we are trying to find. Now we just need to know the top angle right here, which adds up with 2 60 degrees and a 90 degree to form a round angle, which are all the angles at a point. So we know that angle PUQ is equal to 360 degrees, take away 2 of the 60 degrees, take away the 90 degrees. And that's going to be 150 degrees. All right, so it means that the 2 base angles, each of them are going to be equal to 180 degrees, which is the sum of interior angles of a triangle. Take away 150 degrees, which is the top angle, divided by 2, because the 2 base angles are the same. And they are splitting the remaining of the interior angles evenly. So I have 30 divided by 2, which is 15 degrees. So B is going to be the answer for question number 6. All right, does that make sense to you? Okay, let's take a look at question 7 now. All right, so this is a question, clearly is a word problem. And it's on the ratio and proportions. It says that kiwi fruit contain roughly 2.5 times as much vitamin C as the same weight of oranges, which means that for the same weight, kiwi fruit would have 2.5 times as much vitamin C, right? So if they have the same content of vitamin C, it means that, well, the kiwi fruit weigh 2.5 times less than the oranges. So if there's 1 kilogram of oranges, what weight of kiwi fruit contains approximately the same amount? It is 2.5 times less, right? So it means that it's going to be 1 kilogram divided by 2.5 times. Which means the weight of kiwi fruit is going to be 1,000 grams divided by 2.5 times. Oh, let me write this dot a little bit more significantly. And that's going to be 400 grams. 2.5 times 400 is 1,000, because 25 times 4 is 100, right? So if you just play around with the decimals and stuff, you will find the answer easily. That's for question 7. As for question 8, well, a very, very easy and typical date problem. So it's a word problem on date. Today is a Thursday. What day will it be in 100 days' time? So it means that 100 days later, what's going to be the day? We know that every 7 days later, it's going to be another Thursday, right? So if it is 100 days later, then first of all, we can just try to group the sevens by dividing, such that I know there should be 14 complete weeks. 7 times 14 is 98. So there's going to be a remainder of 2 days. So after 14 complete weeks, it is still a Thursday, but the remaining 2 days means that after 100 days, it's going to be 2 days after Thursday. So we just need to keep counting. The next day is going to be a Friday. The next day is going to be a Saturday. So that's 2 days. So the answer is E, Saturday. Okay? That's how we can solve question 8. As for question 9, a counting problem which involves counting shapes. That is not really commonly seen in the JMC papers, but it is quite oftenly seen in like the 11 plus papers and stuff. So how do we count it? We just classify it into different sizes, right? We can see that there are these small squares and these regular squares in this diagram. So first of all, we can try to see how many unit small squares do we have. Clearly, there's going to be 9 of them. So there are 9 1 by 1 small. And then we can see that the small squares can also group up to form these 2 by 2 squares, right? So we have 4 of them. 4 of these 2 by 2 small. And what about 3 by 3 small? Well, of course we can count it, but then it is just as big as a regular square, right? So we don't need to count it twice. We just need to count it once in the regular squares. And there's going to be 9 of them for the regular squares, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 regular 1 by 1 squares, which already involves the 3 by 3 small square. Okay, so we don't need to count it twice. And then we have 4 of these 2 by 2 regular squares, of course, which means that I just add 4 2 by 2 regular squares, and then finally I have a 3 by 3 regular square, which is the whole entire large one, right? So in the end, we just need to add up all these numbers. 9 adding 4 adding 9 adding 4 adding 1. That's going to be equal to 3 of the 9s. That's 27. So the answer is B for question 9. All right, and for question 10 is a word problem on fractions. I would say it's a word problem. Because it's kind of wordy right there, yeah? So half of a quarter of an eighth of a number is equal to that, whatever it is. So what is the number? First of all, we can try to calculate this first. Makes it less complicated. So this is equal to 4/8 adding 2/8 adding an eighth, right? Which is going to be 7/8. Now, that is half of a quarter of an eighth of a number. So if I want to find the original number, I just need to divide each fraction. Because, well, if I am dividing 1/2, it means that I'm reverting it to a quarter of an eighth of the number. If I'm dividing a quarter, again, then I'm just getting an eighth of the number. And finally, dividing an eighth, I get a whole number. Because when I'm dividing the fractions, it converts to multiplying, right? It converts to the multiplication. So doubling it, it becomes the quarter. Multiplying it by 4, it becomes the eighth. And multiplying it by 8, it becomes the whole. Right, so we can just cancel out the 8. Then it's 7 times 2, which is 14, then times 4, which is 56. So the answer is D. Right, as long as you can understand what this question is asking you, it should be easy for you to find the answer by calculation. And then question 11, another special question, which is asked a little bit irregularly. It is actually a number theory problem on divisibility, believe it or not. Because it says that 9 of the numbers are to be put into 2 groups such that the sum of each group is going to be a multiple of 4. So it means that the 2 groups adding up is also a multiple of 4, right? And we are just removing one number. It is asking you, what is the largest number that could be left out? So we are definitely leaving out a number, right? So, which number should be left out? First of all, we know that if I am adding all the numbers from 1 to 10, what I'm getting is 55. Which, if I am dividing 55 by 4, clearly it is not divisible because it has a remainder of 3, right? Which means that if I'm using 9 of the numbers to put it into 2 groups and each of them are multiples of 4, I need to leave the number which is having a remainder of 3 when divided by 4 behind. Which means that the 2 numbers that can be left out are either 3 or 7. Because both of them has a remainder of 3 when divided by 4. And the larger one, 7. So 7's the answer. When you leave out 7, well, you can just literally do any groupings you like. For example, 6 and 10 make 16, and then the rest of them are going to sum up to 32. Which is also divisible by 4, right? So, just do anything you like. As long as one of them is a multiple of 4, the other must be a multiple of 4. Yeah, that's how we can solve this problem by divisibility. Or, well, you can also say that it is the or remainder property. Yeah, maybe it's more about remainder property. Let's say it's about remainder property, okay? And question 12. Question 12. So you can either say that it's a word problem on fractions, because what it is actually playing around is the concept of fractions. Or you can also say that it's a simultaneous equation. How do we spell simo? Oh, I see what happened. Simultaneous equations. Because we don't know the weight of the pot. So it says that when my pot is half full, it weighs 5.8 kilograms, and when it is quarter full, it weighs 3.1 kilograms, which means a quarter of the paint is weighing 5.8 take away 3.1, that is 2.7 kilograms. And as for the pot, it weighs 3.1 take away 2.7, that is 0.4 kilograms. Because that 3.1 is containing the pot weight and the quarter paint weight, right? So we can find the pot weight. And after that, we will know the weight of the full pot. So it's the paint adding the pot, which is equal to 4 times of 2.7, because that's a quarter, which means that the whole is going to be 4 times, right? Adding the pot weight, 0.4. So that's 10.8 adding 0.4, which is equal to 11.2 kilograms. So the answer is B for question 12. Okay, and then for question number 13, this one is a geometry problem. And it's going to be about area of squares. So it shouldn't be too hard, really. It is asking you what percentage of the area of the outer square is shaded. We already know the side lengths of the 5 squares, which means I also know the area of the 5 squares. The largest one is 25, second largest one 16, third largest one 9, fourth largest one 4, and the smallest one is 1. So what's the shaded area? We can see that the shaded area is the second largest one, take away the third largest one, adding the fourth largest one, take away the smallest one, right? So we know that the shaded area is 16 take away 9, adding 4 take away 1, which is 20 take away 10. So that's 20, that's 10, right? So that's 10 as the answer. And of course the unit is centimeter squared, but doesn't really matter because we are looking for the percentage. So the percentage shaded is equal to the shaded area over the total area times 100%, which 100 is 4 times 25. So 10 times 4 is 40, that's equal to 40%. So D is the answer for this question. All right. And then, so we have question number 14. Well, this is a circular interval problem, which also belongs to the interval problems. So think about it, if something spaced around a ring, for example, if there are 3 things spaced around a ring, like my 3 fingers, there should be 3 gaps, 1, 2, 3, right? If there are 4 things, my 4 fingers, there should be 1, 2, 3, 4, 4 gaps. And if there are 5 things, there should be 1, 2, 3, 4, 5, right? There should be 5 gaps between them. So the number of objects is the same as the number of gaps if they are all evenly spaced around the ring. Now we know that number 13 is directly opposite number 35. So how many gaps are there between 13 to 35? We just need to subtract them, which is 22. So 22 gaps is half of the ring, which means that the whole ring has 2 times of 22 gaps, and that's the same as the number of children. So the number of children is 22 times 2, which is 44. Super easy question if you know this principle. All right. And the last one. This one is interesting. I like this question. It is actually a numbers and operations problem. You can see that. But you can see that each numbers are not divisible and the answers are given in fractions, right? So it's actually a numbers and operation problem on fraction. Because we know that essentially fractions are just divisions. So we can write divisions as fractions. First of all, we can have 8 divided by 10 as 8 over 10, which is equal to 4 over 5. And then when 6 is divided by 8 over 10, we have 6 multiplying the reciprocal of it, right? Which means 6 times 5 over 4. And that's going to be equal to 15 over 2. And then 4 is dividing that, which means 4 is multiplying 2 over 15. And that's how we get 8 over 15. 2 is dividing that, so we have 2 times 15 over 8, which 2 and the 8 simplifies to 1 and 4. And that's going to be 15 over 4, which is E. So once you know how to convert a division into a fraction, you can solve this problem. Just need a little bit of observation to see the link between them. If you're just dividing numbers and getting some, well, decimals or recurring decimals, then that's not how you can get the answer. Yep, so that's everything for this first half of this paper. Hope you enjoyed it. And that's it for today. So I will see you on Thursday for the last half of the last JMC paper we're doing. All right, see you then. Bye-bye.